Hello everyone, today we are going to start lecture 03 of class 8 mathematics chapter number 3, which is understanding quadrilaterals. In this lecture we are going to talk about exterior angle sum property and some questions based on it. Now what is exterior angle sum property? We have already studied interior angle sum property, which said that interior angles of a quadrilateral when added makes 360 degree. That is the sum of all interior angles of a quadrilateral is equals to 360 degree. So now let us talk what exterior angle sum property of a quadrilateral says. It states that if the sides of a quadrilateral are produced, it states that if the sides of a quadrilateral are produced in order, comma, then the sum, you can clearly see we have produced the sides of a quadrilateral, so the sum of four exterior angles so formed is 360 degree. So the sum of all exterior angles formed is equals to 360 degree. Again, it is same as the interior angle sum property. It also said that the sum of all interior angles is equals to 360 degree. Exterior angle property is saying that the sum of all exterior angles is 360 degree. Now let us take ABCD as the quadrilateral. You can clearly see we have produced the sides in same order. Now what do we mean by the same order? If you have produced AD like this, then moving clockwise we have produced AB like this. We have not produced AB in the backward direction. Similarly, moving in the clockwise direction, we have produced BC in this direction, not above. Similarly, we have produced CD in this direction, not on the right hand side. So this is the same order. Clearly you can see if you are producing like this, so it is the clockwise direction or any direction, but it's the same direction, right? So do we have a proof for this? Yes, we do have a proof. Let us try to prove it with the help of this figure. Right, let us try to prove this exterior angle sum property. Now let the sides of this quadrilateral ABCD be produced. Let the sides of a quadrilateral ABCD be produced. Okay, let us produce the side of this quadrilateral ABCD. Then the exterior angles are exterior angles formed are angle 1, angle 2, angle 3 and angle 4. Okay, so the exterior angles we formed from this quadrilateral are 4 angles. You can clearly see this angle 1 is nothing but a linear pair with this interior angle A. This angle 1 and this interior angle A together produces a linear pair. Similarly, angle B and angle 2 is a linear pair. Angle 4 and angle D is a linear pair. Angle C and this angle 3 is a linear pair. Simple. So we can say that angle 1, what we can do is we can say that clearly angle 1 plus angle A is equals to 180 degree. How? Interior angle sum property, we have linear pairs, right? We have linear pairs. Similarly we have other 3 linear pairs. Similarly, angle 2 plus angle B is also 180 degree. That will be equation number 2. Angle 3 plus angle C is also 180 degree. Equation number 3. And finally, angle 4 plus angle D is equals to 180 degree, which is equation number 4. So we can clearly see that we have 4 linear pairs which are formed. Okay, now if we add all these 4 equations, okay, If we add all these equations, that is equation 1 plus equation 2 plus equation 3 and then equation 4, then we would get angle 1. LHS would be added, so we will get angle 1 plus angle 2 plus angle 3 plus angle 4. I have taken all these angles together and we will also get angle A plus angle B. We will get angle A plus angle B plus angle C plus angle D is equals to 180 degree plus 180 degree plus 180 degree plus 180 degree. Okay, so we have got this. Now this sum ABCD reminds us of the interior angle sum property. Simply, what is ABCD? These are the interior angles. So what is their sum? It is the sum of all the interior angles, which is nothing but 360 degree. So we can substitute angle A plus angle B plus angle C plus angle D by 360 degree, and on the RHS, by adding all these four terms, we would get 720 degree. Taking 360 degree to the RHS, it would become negative. 720 minus 360 would be 360, so we will get angle 1 plus angle 2 plus angle 3 plus angle 4 is equals to 360 degree. Hence proved. We have proved that the sum of all four exterior angles is nothing but 360 degree. Okay, so that is what exterior angle sum property for a quadrilateral means. But in the case of interior angle sum property, we had a general formula also. For a polygon of n sides, it was n minus 2 into 180 degree, sum of all angles. And if the polygon was regular, we would divide by n to get each measure of the angle, right? Similarly, we do have same kind of formula for n side of polygon also, right? So exterior angle property is also defined for a polygon of n sides, and the result would be very strange. So let me write the statement. What does the exterior angle property for an n-sided polygon says, right? It simply says that the sum of all the exterior angles formed by producing the sides of a convex polygon. Okay, it can be any n-sided polygon, sides of a convex polygon. Again, what in same order? Convex polygon in the same order. Again, the order should be same. Okay, produced in the same order is equal to 360 degree, right? So the sum of all the exterior angles formed by producing the sides of a convex polygon in the same order is equal to 360 degree. Isn't it strange that when the sides were 4, then also the sum was 360 degree. When the sides have become 5 in this figure, then also the sum is 360 degree. And the formula is simply saying that whether the sides become n, it should be 10, 20, 30 sides. Then also the sum of all exterior angles would be 360 degree. So it is a strange, that is, as you increase the number of sides, each exterior angle becomes smaller and smaller because their sum is constant. So their contribution is becoming small because their number are increasing, right? So there is a remark which follows after this property, and it states that each exterior angle, each exterior angle of a regular polygon, each exterior angle of a regular polygon of n sides is equal to 360 degree upon n. right? So each exterior angle of a regular polygon of n sides is equals to 360 degree upon n. So that is, if you have 10 angles, then each exterior angle would be 360 upon 10, that is 36 degree. If you have 5 sides, then it would be 72 degree. If you have 3 sides, then it would be 20 degree each. That is for a triangle. For a quadrilateral, for a regular quadrilateral, that is a square, this n is equals to 4, and we will have each exterior angle to be 90 degree, which is true also. So you can clearly see that for regular polygon or whether a non-regular, when you increase the number of sides, each exterior angle, value of each exterior angle decreases. Okay, so this was all about exterior angle property for a polygon and a quadrilateral. Now let us do some questions based on these formulas to make the concept stronger. In this question we have to find the value of x in the figure. Now the figure is nothing but a quadrilateral, so we know that sum of all exterior angles of a quadrilateral is 360 degree. Okay, sum of all exterior angles equals to what? 360 degree, which implies that x plus 90 degree plus 50 degree plus 110 degree is equals to 360 degree, which simply says that x equals to, now this 110 plus 90 equals to 250, 250, so we would get 360 degree minus 250 degree, and we would get x equals to 110 degree. So it was that easy to solve this question on the basis of exterior angle sum property, right? So what we did was we just added all the 4 exterior angles to be 360 degree, because that is what exterior angle property simply says, right? So let us take another question on the same concept. Find the number of sides of a regular polygon whose each exterior angle measures 45 degree. So we have already given the exterior angle is 45 degree, right? We have to find the number of sides of a polygon. Let the polygon have n sides. Okay, let the polygon has n sides. Now for a regular polygon of n sides, each exterior angle is, for a regular polygon of n sides, comma, each exterior angle is nothing but 360 degree upon n, but this angle is given to be 45 degree, but it is given to be 45 degree. So 360 degree upon n is equals to 45 degree, which simply means n equals to 360 degree upon 45, which is equals to 8. So the polygon has n sides. So the polygon has 8 sides, right? So there are some sides. Okay, we have assumed it to be n. Now the question simply states one thing, that exterior angle is 45 degree, and we know that exterior angle actually depends on the number of sides. So that was the question, and that was the concept behind the question. Okay, so it was very easy, formula based question. Let us take another question on the similar concept. What is the measure of each angle of a regular hexagon? Again, if a hexagon is regular, then all the angles are equal. How many angles are there in a hexagon? In a hexagon, comma, there are 6 sides and 6 angles. For a regular hexagon, having each interior angle as x degree, comma, sum of angles is equals to what? You can clearly see that if a hexagon has 6 sides and 6 angles, then a regular hexagon will also have again 6 sides and 6 angles. It is a hexagon at the end of the day, right? But for a regular hexagon, if the interior angle is x degree, suppose one interior angle, then all the interior angles are equal, because for a regular hexagon all sides and angles are equal. So sum of angles is equals to 6x degree if each exterior angle is 6x. But we know that sum of all the angles of an n-sided polygon is n minus 2 into 180 degree. Okay, but sum of all angles of a polygon having 6 sides is equals to what? N minus 2, that is 6 minus 2 into 180 degree. Now that has come from formula, that has come from our logic, right? Both are true. So which implies that 6 minus 2 into, that is 4. So 4 into 180 degree is nothing but 6x degree. Because if your measure is x, then the sum is actually 6x, x plus x, 6 times. And according to the formula, the sum should be this, 4 into 180 degree. Dividing both sides by 6, we would get x equals to 4 into 180 degree whole upon 6. Dividing 180 from 6, we will get 30. So x is equals to 120 degree, right? So each interior angle of a regular hexagon is 120 degree. So each angle of a regular hexagon is 120 degree. So that was the measure of each angle of a regular hexagon, right? Let us take another question. Now this question simply says that the interior angle of a regular polygon is 156 degree. Find the number of sides of the polygon. It is again very simple. Okay, let the number of sides in the polygon be n. Let the polygon has n sides, right? So the polygon has n sides. Now it simply states that the interior angle of a regular polygon is 156 degree. Now for a regular polygon, that the polygon has n sides. For a regular polygon of n sides, the value of each interior angle is, for a polygon, or we can say for a polygon or a regular polygon. Specifically this formula is for regular polygon. For a regular polygon of n sides, comma, each interior angle is now sum of all interior angles was n minus 2 into 180 degree, and since for a regular polygon each angle is equal, so if we divide by n, we will get the value of each interior angle. So this was the value, but it is given to be 156 degree, but it is given to be 156 degree. That is, if we equate both the conditions, n minus 2 into 180 degree whole upon n is equals to 156 degree, and cross multiplying the n, we would get n into 180, that is 180n minus 360 degree is equals to 156, and we have cross multiplied this n, bringing 156 to the RHS. 180 n minus 156 n equals to, taking this on the RHS, we will get 360 degree. Subtracting this, we will get 24n is equals to 360 degree. Now dividing both sides by 24, we would get 360 whole upon 24, which is equals to 15. Okay, so clearly the polygon has 15 sides. So the polygon has 15 sides, right? So this was again formula based question in which we just applied the formula of each interior angle for a regular polygon and then equated it with the given value. Okay, so let us take another question with the exact same concept, just with the different value. How many sides has a regular polygon, each of which is of measure of 108 degree? Again, take the polygon to be n sides. Let the polygon has n sides, right? Now again it says that each interior angle is 108 degree. So what we can do is, according to the question, each interior angle of a regular polygon, which is nothing but n minus 2 into 180 degree whole upon n. This is the each interior angle of a regular polygon. It says that this is given to be 108 degree. Cross multiplying both the sides, we will get 180 into n minus 360 degree is equals to 108 n. Right, now 108 n minus okay, let me bring 108 on the LHS. Okay, so it would become, so the answer would be plus and would be easy. So instead of taking this on the RHS, let us bring 108 on the left hand side and we will get it as minus 110. Taking this minus 60 to the RHS, we will get plus 360 degree, right? Subtracting them, we will get 72n is equals to 360 degree. Dividing both sides by 5, we will get, both sides by 72, we will get n equals to 360 degree whole upon 72 degree, which implies that n equals to 5. Okay, so n equals to 5. So how many sides a regular polygon have? So the polygon has, so the polygon has 5 sides. Now let us take one more question, okay, on the similar concept, in which we will equate both the formulas. Okay, we will make the use of both exterior angle formula and interior angular formula. So this last question says the exterior angle of a regular polygon is 1/3 of its interior angle. So the exterior angle of a regular polygon is 1/3 of its interior angle. How many sides has the polygon? Again, let the polygon has n sides. Okay, let us start the question like this. Let the polygon has n sides, right? So the exterior angle of a polygon, now for a polygon of n sides, for a regular polygon of n sides, exterior angle is equals to what? Exterior angle is equals to 360 degree whole upon n, and interior angle for a regular polygon, we know that interior angle is equals to n minus 2 into 180 degree whole upon n. So this was the interior angle, right? Now the question says this exterior angle, now what the question says that this exterior angle is equals to 1/3 of the interior angle, that is n minus 2 into 180 degree whole upon n, right? So we would get 360 degree whole upon n is equals to, multiplying 180 on this side, so we will get 180n minus 360 degree whole upon 3n. Multiplying both the sides by 3n, we would get 360 degree upon n into 3n is equals to 180n minus 360 degree upon 3n into 3n. So this will cancel out 3n, n will cancel out from n, and 360 into 3 will give us 1080 degree is equals to, we would get 180n minus 360 degree. Taking this 360 to the LHS, we would get 1080 plus 360, so we would get 1440 degree is equals to 180, and dividing both the sides by 180, we will get n equals to 1440 whole upon 180 cancelling out the common factors, we would get n equals to 8. So the polygon has n sides. So the polygon has 8 sides. So this is how you solve a question based on exterior and interior angle properties. Okay, I hope you got the lecture. This was all about exterior angle property, but in this lecture we have also used interior angle property and its formulas as well, so that these questions should have strengthened your concept. So this was all about this lecture. Thank you for watching this lecture till end. I'll see you in the next lecture. Till then, goodbye.